Hi, question number 6. The points A, B and C have position vectors 2i minus j plus k, 3i plus 4j minus k and minus i plus 2j plus 4k respectively. Find the area of the triangle ABC. Now first of all, I'd like to list down all the vectors. We have got OA as 2 minus 1, 1. OB is 3, 4 minus 1. OC is given as minus 1, 2 and 4. The first thing to do is let's first of all do an illustration here. So we've got O is somewhere, we've got A, B, C as the triangle. So I'm going to try to find the angle in between these two vectors. First I need to find the vector AB. Now you will agree with me that AB is equal to, if you work this out, minus 2 plus 1, okay, that's going to be, AB, sorry, minus 2 plus 3 is 1, 1 plus 4 is 5, I've got minus 1 plus minus 1 is going to be equal to minus 2. Similarly, I've got AC as well, so minus 2 plus minus 1 is going to be minus 3, minus 1 plus 1 plus 2 is 3, and then 1 plus 4, minus 1 plus 4 is going to be equal to 3. So that's the vector AB, AC and AB. Alright, we need to find the length of AB. So AB is going to be equal to the square root, that's the magnitude of AB, 1 square plus 5 square plus minus 2 to the square, and all of that's going to give us the square root of 30. So this is the square root of 30. And I'm going to find vector AC as well, the magnitude of vector AC, that is 3 square plus 3 square plus 3 square. I'm not too worried about negative here because it's going to become positive anyway if we square it, so that's going to turn into 3 root of 3. So this is 3 root of 3. We can find the angle between the two vectors. We've got AB and AC, so the cos of BAC can be given as AB dot product with AC and then divide by their magnitude. And if you were to do this, AB, which is 1, 5 minus 2, and then minus 3, 3, 3, divide by their magnitude, root of 30 times 3 root of 3, and therefore angle BAC turns out to be inverse cos of 6 over root of 30 times 3 root of 3, and that's going to give us root of 10 over 15, and therefore the angle BAC is going to be equal to 1.358 radians. Now that we found angle BAC, we can find the area of the triangle. So the area of the triangle, area of triangle ABC, is going to be half AB times AC times the sine of the angle between them. If you were to do that in your calculator, you should be able to get 13.9 centimeters. So I'm saying centimeters square, it should be unit square anyway, that's fine. So this is how we find the area of the triangle, of the vector triangle ABC. For the second part, find the perpendicular distance of the point A from BC. Now let us suppose that this is the triangle ABC again, and now what we're doing, we're saying the distance here, we want to find this distance here. Now remember, these are the vectors So if we want to find the distance, we can use the formula that distance is equal to cross product of the vector AB and BC. I mean vector AB and BC. Yep, AB and BC. And take the magnitude, the magnitude of their product, and divide by the magnitude of BC. Now we need to find this first. How do we cross product? So let us say I want the cross product. I'm going to use the matrix method. We've got IJK. So the thing is, here we go. This was the vector AB as found in the earlier part, and the vector BC is going to be -4, -2, and then 5. So 5 times 5 is 25, minus 4 is 21. And I've got 1 times 5 is 5, minus 8 is going to be equal to minus 3. And also minus 2 minus 20, that's plus 20, is going to be 18. And then an equivalent of that vector, alright, is going to be equal to 21, 3, and 18. Now this is the product, cross product of AB and BC. We can find their magnitude, alright, in a moment. We did find the magnitude of BC in the earlier part of the question. BC, did we find BC? I don't think we have found BC. Alright, so let's find the vector BC first. BC is BO plus OC. And what is BO? So minus 3 minus 4, 1. Minus 3 minus 4, 1. Plus OC, and OC is minus 1, 2, 4. Add this up, and that's going to turn into minus 4, minus 2, and then 5. So this is BC. I'm sure we can find the magnitude of BC now, which is the square root of minus 4 to the square plus minus 2 square plus 5 square, and all of that should give us square root of 45. Okay, so we just need to plug in these values into this here and find the distance, the perpendicular distance of A to the line BC. Alright, point A from the line BC. So distance is now equal to the magnitude of AB times BC, and AB times BC is this, so the magnitude of AB times BC, what is the magnitude of that one? It's going to be the square root of each of these to the square. 21 square plus 3 to the square plus 18 square, and work this out and your calculator should be able to get a root of 774. So that's going to be root of 774. So AB times BC divided by root of 45, that should give you 4.147288 and so on. Therefore the answer to the question is 4.15 units. Here we are for the second part to this question. For the third part of the question, find the Cartesian equation of the plane ABC. Now we are looking at the plane ABC. We did find a normal vector to the plane in the second part. Let us take a look at the second part here. The normal to the plane is 21, 3, 18, and that gives us the equation of the plane. So that's going to be 21x plus 3y plus 18z. So 21x plus 3y plus 18z is in fact the equation of the plane. We just need to find D. We can substitute the point A into D. Remember, the point A was given in the question as 2 minus 1, 18. So we're going to sub A, that is 2 minus 1, 18, in this equation here. So therefore we got 21 times 2 plus 3 times minus 1 plus 18 times so that's 18. Oh, sorry, that should have been 1. 18 times 1, and that's going to give us D. So D is going to be equal to 42 minus 3 plus 18. 57. So that's going to be equal to 57. Therefore, Cartesian equation of the plane ABC is given as 21x plus 3y plus 18z is equal to 57. We can divide both sides by 3. And therefore we have 3 divided by, 27 over 3, 21 over 3 is equal to 7. X plus y plus this divided by 3 is going to be equal to 6. Z is equal to 3 here, 19. And here we are for that equation. Take care.